My name is Richard Henderson. I'm the EMEA Technical Director for TigerGraph. What I thought I would talk to you about today was less about trying to sell you on the technical aspects of graph databases and where we fit into it. I think if you go to our website, we have amazing marketing which covers all of that general purpose stuff. What I really wanted to do was talk about specific ways in which people are getting value from it, and a use case that's very dear to my heart. So I will move quite quickly through the slides. I don't want to bore you too much with slides. I've got a demo to show you as well, if I can pop it up on the screen, which I will do later. And that's the point where it all sometimes goes wrong. So we'll see where it goes. But this is a brand new demo, and the title I've got on here is that in 2020 we took a process at Jaguar Land Rover specifically, which took 2 weeks. It was to make it into 45 minutes. Originally, the problem was that if you have a problem during manufacturing process, then it's a little bit tricky and very expensive. Generally, in manufacturing, it can cost millions of pounds a day to shut down factories. And so obviously when things go wrong, they want to be able to avoid that shutdown as quickly as possible. And previously, they kind of had to just improvise, because it took 2 weeks for them to analyze what was the best approach, which clearly is far from ideal. What we did was we developed a prototype for them that they actually used immediately, because a problem happened about a week after we went live with it, which was kind of both lucky and unlucky because it demonstrated the worth. And it took them 45 minutes to come up with a good alternative solution instead of the previous 2 weeks. Harry Powell from JLR, he talks about this on a presentation which you can find on our website, which is very interesting. He works for Jaguar Land Rover, so you don't have to believe me. He can tell you all of the details around that. But this year, I really wanted to take it to the next level. I have a background. I worked for Toyota for many years. I've worked in financial services and also in retail. And all of them really emphasized to me that real time, particularly in the operational space, was kind of everything. You wanted your operators to have all the information that they needed at hand as rapidly as possible so that they could effectively deal in real time with the problems as they occurred. So if I go to the next slide. So this is what we call the giant three-circle view, which really talks about all of the ways in which our product is used. So we talk about advanced analytics and machine learning on connected data. So that's I could unpack this entire slide for you, but we'd run out of time very quickly. But just briefly, the top level features that TigerGraph has that is unusual in the market, and what is why we are getting so much attention at the moment, and indeed successes. First of all, we are a distributed graph database, as you can see from the orange circle. What does that mean? It means that we can be, you can install a single graph database across multiple machines. And we also do the processing of queries a lot across multiple machines, which gives us pretty much unique performance, both in terms of getting data in, because we can load all of the machines in parallel, as well as giving us very, very high throughput, very low latency. It gives you everything that you want from a database and allows you to scale out. And particularly in the era of cloud and big data, that's quite important. Advanced analytics, Graph, because it connects all your data together immediately, it expands the scope of your analytics. It also allows you to do network type things like community detection. And it could be a community of new customers that you want to sell to, or it could be a community of bad guys that you don't want to sell to. And any kind of your standard analytics, but really expanded so that it covers an entire chain of activity. Another one is in database machine learning. It's very useful to have AI and ML these days and apply it to your data. But what we do is by bringing that back into the database, we allow you to get the kind of speed that you're looking for. And I won't go, as I say, I won't go into a tremendous amount of detail on this. Again, we have fantastic resources, and I'm hoping that if people get this deck afterwards, they'll be able to click on things and they'll be able to look at this and look at the references. But really, I bring this up just to make the point that we are much more than what I'm going to talk about today. So this is the way I've kind of boiled this down. So why do I work for TigerGraph? And the way I look at it is that we're kind of the first 3 out of 3 graph database. We've had, there are a number of other technologies. Some of them are very big, so they handle big data, and so therefore scale is not a problem for them. But generally, they're quite slow. They're a bit batchy. Some of those things which are based on Hadoop. And so as a result, they tend not to be able to deal with real-time use cases, which are the ones that I really care about. Then you have databases that are fast, in that they can, then now you're starting to do real-time. We are probably the fastest, honestly, and we have benchmarks for that. But nevertheless, the point is that for real-time, you absolutely need to have millisecond latency. You need to be able to run your queries very, very, very quickly. And some databases can do that. Then you have smart. And what do I mean by smart? Smart can mean any number of things. But for me, it means that you have to be able to do more than just get the data. You need to be able to operate on the data. You need to be able to do things like scoring. You need to be able to find things like the ranking of different parts. You need to be able to follow many paths and follow very deep paths. We talk about deep link a lot. Generally, the whole point of a graph database is that you want to be able to see an awful lot of the data. You just don't want to deal with a single point query. And so that's exactly what we offer as well. I've put some things around this just to qualify those with a few numbers. So in terms of big, what does that mean? We've got installations right now running 30 terabytes raw data. That's on commodity, well, big commodity hardware, but that's 40 or 50 nodes those run on. Those are replicated and all those other good things for reliability, but fundamentally the data sets that they're running on are 30 terabytes, and that's for real-time querying. For JLR on I have to say, much smaller sized set of machines running on Google Cloud, we imported 6 months of their production forecast, which ends up being around about 4.5 billion parts. So we were able to do a full linkage all the way from supplier through to the car being built and then the car being sold onwards. So the entire chain of activity for about 4.5 billion parts. So in principle, at least, if something breaks on a car, then in any of those 4.5 billion parts, we can trace it all the way back to source. And that's important for what I'm going to show you in the demo. For the latency side, there's 2 parts to this. One is how quickly can you get your data in to the database? Do you have to take the database offline while you're doing it? To which the answer is very fast indeed. Gigabytes per second for us is not unusual, particularly for the larger clusters. Once you've got the data in there, and that's online as well, so you can load the data while you're still using the data. You don't have to wait for indexing or anything like that. This is that's an online performance. We have offline loaders as well if you want them, but frankly, very few people need them because they're not unnecessary. We also talk about, it says MPP on there. What I mean is massively parallel processing. Our system can process queries across the entire cluster. We run what we call a thread per edge. What does that really mean? It means that we run these difficult analytical queries pretty much as fast as they can go. We generally will max out all of the CPUs you can give to the machine. And that is for pretty much any scale and for any query. And of course, all queries run in parallel as well. So therefore, you're not only getting the best performance for an individual query, and that's without any tuning required particularly. It just always works that way. And also, you can have parallel queries going on as well. So again, it's this idea of OLTP and OLAP, so between transaction processing and analytical processing. We're much more in the hybrid space where you can really do either, and we rely on our speed in order to be able to service both of those workloads. And in the example for this is that for JLR, we talked about 25 minutes. Actually, it took us 5 minutes to produce a fully sequenced alternate build pipeline. And that meant that the factory didn't have to stop at all. None of the production lines, build lines, had to stop for more than a couple of minutes. And those 2 minutes were standard downtime while they changed the tools according to the cars that they were building. And it meant that they could carry on building cars, even though one of the parts that they received was actually broken, and that effectively meant that their entire day's production on this particular production line could not be built. So within 5 minutes, we had provided a complete alternate sequence of build in sequence, which allowed them to basically carry on as if nothing had happened. And that gave them the time, obviously, to go back to the supplier and to get the replacement parts. In terms of the smartness, rather than go on about the analytic smartness, I really like to talk about the cloud smartness. We're very cloud native these days. We provide APIs and dashboards that allow you to effectively build a cluster on demand. And because we can load the data so quickly, that makes sense. And so if you have a particularly long running task that you want to run once, then that's fine. If you have other systems that are going to run continuously, like operational systems, then that's fine. And you can create and destroy these exactly as you need to. So it also covers all your DevOps and DataOps pipelines. And we are very well integrated with standard pipelines on cloud. So far, a bit techie. Hopefully I'm not boring you too much. This is really providing the context to say it's really easy for us to use TigerGraph. We see that as our mission in many ways, is to try and make TigerGraph easy for people to use, to try and bring this kind of power that people haven't really had before and make it available to people so they can use it very easily. And nowadays that means cloud. Let's talk about base architecture. Again, a little bit dry, but if you go to GCP, it looks a bit like this. On the left, events come in, and on the right, it goes through various pipelines, and ultimately it comes out into the displays on the right. So a very simple pipeline. What we did to make it easy to use TigerGraph was we did this. We just basically added TigerGraph into the bottom. We used our standard interfaces and effectively augmented the data warehouse that was in BigQuery. And that's what immediately gave them the ability to do these kinds of queries incredibly quickly, but did not have to disturb their standard pipeline. They could still use Tableau. They could still use all of their standard tools in order to do this. This is what we're doing this year. And this is really, we're really getting into the real time. First of all, whereas before TigerGraph was a marketplace license that you spun up on your own machines within cloud, now we're offering database as a service on cloud as cloud partners. This is on all clouds. This particular one is showing Google, but nevertheless, it's on all clouds. You can buy it through the marketplace. You can buy it through Google, so you don't need new procurement processes. You can deal with your standard agreements that you have as part of the cloud. And so again, this is just making it really easy for people to take advantage of this technology without having to change anything that they're doing already and to align with what they would normally be doing with the cloud providers using their native facilities. So we want to be the cloud native graph database effectively, and that's what we're doing here. And the other thing that's different here is now we have a stream coming in from real time, and this is what's really important for the real time is I want it so that it is real time, so that operations people, if you can recall what I talked about originally, can do things really fast. This is essential. It's the big deal on this demo. So let's get to the real stuff. And this is where I cross my fingers and toes a little bit. So this is a demo which we're doing right now. So this represents could be a supply chain, could be a data operations chain, could be anything where you have, it could be logistics. It's anything where you have a supply on the left, which moves through a sequence of operations and ultimately ends up on the right. And we've custom built this user interface really because we want to make the point. This is real time. This is just pulling database straight out of the system as fast as it can be pulled out of the system. This is the key point in all of these things. So if we look at this, and I can zoom in a little bit. Generally, for an operations, there's only a couple of questions. First of all, when things break, where is it broken? So immediately we're seeing that this is broken, and the database is immediately providing contextual information, which allows you to see what the problem is. I presume this is JLR's new car product that they're producing. But the point is that, say you have a customer who's just said, where's my car? I haven't got my car, or something is broken. Or it could be, my reporting job has failed. Where is my data? And so the first thing they want to do is immediately find out where has it failed. And so you want to be able to, in real time, see the entire chain of events all the way back to the start. Once you've got that and you're looking for, and we can see there is a problem here, then immediately you want to say, okay, so who does this affect? And I think people forget this in operations. The first thing you worry about is how important is this? So we know that we've got one problem with one customer complaining. So immediately we want to see the impact or the blast radius, which we want to see. And this in real time immediately shows us all of the downstream customers. Obviously, this is simplified. It's for display. But remember, we can do this for 4.5 billion parts. This is all done in real time, interactive with the database. And immediately at this point, we now can start getting ahead of the problem. We know what the impact is likely to be, and so therefore how seriously we need to take it, who we need to call, do I need to get the boss out of bed or not? Which customers do I need to talk to in order to say, please, can you fix this? And the other thing we can help with then, using exactly the same model, is in 5 why analysis or in root cause analysis, is where did this come from? And if we look here, we can see that, if I can just work the UI properly, we can see that it actually comes from upstream from here. The upstream event comes from here, and this is a change event that occurred before this reporting problem. So now we need to know, what's it worth to me to actually fix this? And actually we can see that this upstream event has enormous scope for impact, and so therefore we need to fix that. And that really is the demo. So the idea is to give operators exactly this capability. What went wrong, when it went wrong, why did it go wrong immediately, what's the immediate cause, the proximate cause of it, who is impacted, who do I need to call? All that, just answering those questions quickly, which people have great difficulty with now because they don't have this full flow view of it, is very, very difficult to do. That's the demo. This is our standard pitch that if you do want to come on cloud, then you can start in minutes. You can we'll build it in hours. Some people build it in much less than hours. And this is for your initial build. We will help you with this. We'll give you starter kits and everything that you can do. And ultimately, you can effectively deploy into production in a matter of days. We have people doing this way faster than this because they've got infrastructure as code pipelines, and they're managing to do this in, they're spinning up environments in minutes. So again, it all goes to the idea of we want to make this as fast as possible. So I'm looking at my timer. How much have I got left? So I guess if there's any questions, I'll have a quick look and see if anybody's asked a question. Nobody's asking questions. Okay, I've got a whole load of other questions that people already, standard questions that people ask me. I'm very happy to talk about. If you want to put questions into the Q&A box on the right, then I'll answer them directly. And I'm just going to keep going until basically somebody tells me to stop. So if we go through, let me see if I can get back to my deck. So I'll leave the resources page up. This is, again, it'll be on the deck. We'll try and get it distributed to people who want it so that people can actually do it. This has got every link you'd ever want. And of course, you can always get hold of me directly, Richard H. at TigerGraph.com. But coming back to the standard questions we have. So one of them is the obvious one, are we available on every cloud? I've only talked about Google. Yes, we're available with pretty much the same status on Amazon, Azure, and Google. All those are available to us. Do we have on-premise licenses? Yes, we do. We can provide any kind of license. We started off with on-premise license, and we're kind of moving to this database as a service, and thus we can actually support hybrid setups. Some people have some of their data on-premise and some other data they'll have on cloud, depending on what their use cases are and how confidential it is. And so we can work that way. That's totally fine for me. Can we spin up on demand? Yes, we're generating, we've got REST APIs for pretty much all of it. And that means that you will be able to put this as part of, if you have a DevOps pipeline, it's very easy for people to spin up development and test and even production systems if they want to, using those APIs. And so it integrates with standard DevOps pipelines to integrate with what if you architectures that you want to set up. Where does AI fit in is always the other one. I think, and that's kind of a big question. So up to now, we've talked about real time, but if I go back to this actually is a pretty standard, if you talk to architects, they'll talk about Lambda architectures a lot. And that's a fast and slow. And so on the bottom, we've got the batch, which is the slow side. And what happens is this is used to feed the training systems, your machine learning systems, so that they can learn. And then on the top, the fast side, once they've trained the model, then the fast side, it's there so that when they run the model, then they can use the same data, the same facilities they've got from Graph, so that they can then run it. And we have, for example, a telephone company using it to stop fraudulent calls, and they're running at a few million operations per second. And so in order to get that kind of speed, they have to be able to run it very, very rapidly against the database. And that's exactly what we're doing for them. So when you're doing AI and ML, it's easy to do it in batch, but once you get into real time, then you need to be able to feed it. That's a key point. Let me see, how much longer have I got? Oh, it's a while longer. So I guess what I'm saying is that in the AI and ML world, we often talk a lot about batch type operations, business information operations, and so BI tools, AI, ML, strategic. But for me, a lot of the value, if you want to get value very rapidly and very tangibly, then for me, that's why it's very interesting to look at the real-time case. So I think that if you want to be able to exploit the same techniques, the same value that you're seeing in the business information space, and bring that back into your operational space where time is literally money, where seconds absolutely count, then you really do need to have the kind of database that I was talking about at the beginning, which, if I can find it, is this. You need this 3 out of 3 graph database. You need something that's big enough to handle the data you've got at the scale that you need it, as often as you need it. You need it to be fast, so that because you want it to be actually real time, you don't want to be waiting an hour for the answer, that you need to be able to use user interfaces like the one I showed you, where there is real-time interactivity with the data. And finally, you need it to be smart. It has to be able to do useful things with that data in real time. If you can't do the clever things in real time, if all you're doing is getting the data in real time, you're kind of missing out on part of the value there. And that, my friends, is everything I've got for you today. I will leave up the Q&A screen until they pull me offline. I'm very happy to answer questions. Otherwise, please do get in touch, and hopefully we'll speak to you soon.